Professor Gavoor again with Chapter 15, Part 2. I believe we ended at this slide on external sources. And we're talking about data that can be bought from third parties and how you integrate them. Part of it was, not even buy from third parties, but for example, if you're a consumer goods company and you sell to retailers who sell to the consumers, you want to find out how people are buying from them so they would provide their data for you so you could do more accurate forecasting. So who's collecting data about everyone? Well, data aggregators, first of all, so many websites that you log in for, talks about having cookies, talks about having data that they share with others or don't share with others. You can opt in or opt out. I mean, if you watch that movie, The Social Dilemma, Facebook doesn't exist for you. Facebook exists for advertisers. You exist for Facebook to deliver them to advertisers. So you're not really a customer, you're the product, actually, according to that documentary, which is kind of special. So one has to be aware of digital tracking of individuals. And it's just the vast amount of personal information online. At the same time, I make a joke all the time. I go look for something like an electric mandolin. I buy an electric mandolin online, and for the next month, I'm getting advertisement on every social networking website I go to offering me electric mandolins. I'm like, if they're smart enough to know I want to buy one, don't they know that I actually did buy one and probably won't buy another one? The internet allows for easy access of data that has been public but is otherwise difficult to access. In other words, you don't need any special permission for some databases, especially government databases, and if you can access them properly. It's sometimes a pain to try to get it to talk to your system to bring the data in, especially if it's large data sets. There are accuracy concerns with some of the data. I don't know about the terror watch list. It has several embarrassing high-profile errors in its data. I don't know anything about that. Sometimes data aggregators are just plain sloppy, committing errors. So you've got to really look at the data they're using and the integrity of the site you're using from third parties. If you're using data from Walmart and you're a supplier of Walmart, their data is going to be probably clean or as clean as any other data you're going to get. The falling cost of storage and the increasing reach of the internet is what, well, they say it has on the cusp of a privacy train wreck. I don't know about that. It certainly has is on a data. Is there a privacy? Is there not privacy? I don't know. You can get off of everything except maybe Amazon. The only website I really like to buy anything from is Amazon. Everything else works wonky. And they have almost everything that I would want to buy online. I hate to be a captive customer, but that's the case. So many industries have strict guidelines on what kind of information can be collected and shared. International laws also differ from those in the U.S. Facebook and Google faced a lot of privacy issues in Europe in the past couple of years. And the public certainly will demand tighter controls as this goes forward. You got to watch out what you get for free. A lot of Google is free. A lot of Facebook is free. Facebook owns Instagram, which people hate Facebook, but use Instagram. A lot of people use their messaging service, WhatsApp. And you don't get all that stuff for free. It's not free. Your information is what you pay for using those free sites. So, no one able to list the reasons why many organizations have data that can't be converted to actionable information. Understand why transactional databases can't always be queried. What needs to be done to facilitate effective data use for analytics and business intelligence, and recognize key issues surrounding data and privacy legislation. So data-rich, information-poor. Like you can have a mountain range of data, but you can't turn it into information. That's why we're creating a small army of data analysts, data scientists, data engineers, and their job is all to try to extract information from these databases. And as you create new ones, you want data scientists and data engineers to create the databases so you can get maximum benefit out of it. So legacy systems, these are the older systems that are incompatible with other systems. And how do you access that? Operational data cannot always be queried. Most transactional databases are not set up to be simultaneously accessed for reporting and analysis. Well, in the modern business world, if you're using SAP and Oracle, they are designed exactly for that. And they create a separate database called a cube or something similar to that, where you have the transactional database that you're running your business on, but then you have a shadow database that you can use for all your analytics, and it gets updated on a regular basis from the primary transactional database. And that's, I think, how many of these things work. Understand what data warehouses, data marts are and the purposes they serve. Now they have something called a data lake, which I think Amazon kind of coined that term. Know the issues that need to be addressed in order to design, develop, deploy, and maintain data warehouses and data marts. And recognize and understand technologies behind big data and how they're different from conventional data management approaches. I mean, as I told you before, the amount of data can't fit in an Excel spreadsheet. And an Excel spreadsheet can take a lot of data. So a data warehouse is a set of databases to support decision making in an organization. A data mart, database or databases focused on addressing concerns of a specific problem or business unit. They're structured for fast online queries and exploration. I think maybe my data cube has been replaced by data warehouse and data mart. Collects data from different operational systems. Marts and warehouses can contain huge volumes of data. Building large data warehouses can be expensive and time consuming. But if you're using SAP and Oracle, your own data inside your company is probably already accumulated that way. And it's for you to go in and decide how you're going to use it. Large-scale data analytics should be built on visions with business-focused objectives. Well, what's the purpose of doing a big data analytics study if it's not to make a more sound business decision? You're trying to get insights to make better business decisions. It's not like, I don't know, I'm curious, what are teenage girls buying this week? Is it the same thing they were buying last week? Isn't that curious? No, that's not why you do it. You want to find out what the trend is in teenage girl shopping patterns and take advantage of it by focusing your promotions to that client base or to that customer base in a way that gets them to spend more money at your store. Isn't that the objective? So firms can address broader issues needed to design and develop these things. So you're always looking at relevance, sourcing, quantity, and quality, hosting, and how do you govern these things. It's been a while since I've been involved in that part of the business. When I left industry, I was pretty well versed in some aspects of it. But I would say the biggest issue when I left was quality, making sure the data was of high quality. And in a transactional company like a consumer products company like Nua Rubbermaid and Colgate Palmolive, where I spent bulk of the last half of my career, that data is readily available and ready to be mixed and matched and sliced and diced and get whatever insights you can out of it. Now, we're just on the verge of using outside databases. So you have information systems for operations, and then you have information systems for analysis. So this is exactly what I talked about. You have your database here where you're doing your transactional stuff. You're taking orders, you're placing orders, you're making purchase orders, you're planning manufacturing, you're transferring goods from the factory to the warehouse, from the warehouse to logistics, from logistics to the customer, all of that kind of stuff. And you're keeping track of that. Now, each one of these transactions all of this has several different databases associated with it. On an ongoing basis, you either create a shadow version of that database or probably a modified version that's easier to access and do the slicing and dicing and selecting sub-data sets from it so that you can do your analytics. So they create a data warehouse and it's updated, so it's separate. So you don't want these people doing the analysis screwing around with your transactional database and slowing it down. Separate. And that's the point of this picture. So you have a data warehouse that goes to a data mart. These people then access that. Sometimes if the data sets are smaller, you download them to Excel. If not, you've got to use something like Python that can handle large databases and the manipulation thereof. Okay, so one of the things is big data, data lakes, Hadoop, and related technologies. There's 3 V's, volume, velocity, and variety, that distinguish it from conventional data analysis. And it's the speed with which you want to do the analysis. If you have a database that almost takes up all of Excel, a data set, it will slow your computer down to a crawl. You can't even, your laptop. Normally, if you have, any normal size, regular, even a huge Excel file, you can manipulate rather easily. But as soon as you fill it all up with data, all of Excel, from column A to quadruple ZZZ, and from 1 to 10,000, 10 million, 10, I don't even know how big it goes. It slows it down. So you want to be able to do this. You want to handle ridiculously large volumes fast. And you want to have the variety of kind of data that you have shouldn't matter. So you have this thing called a data lake. It's a catch-all term for storage and access technologies used in big data. So however the data is, you dump it all in a lake and then sift through it, I guess. Hadoop is a set of open source tools to manage massive amounts of unstructured data for storage, extraction, and computation. Advantages: flexibility, scalability, cost effectiveness, and fault tolerance. And if you build a Hadoop program or application that works for you and helps you, and if you're going to do it on an ongoing basis, you can save it and keep running it. The same is true for Python, which is another one. E-discovery, supporting legal inquiry. So identifying and retrieving relevant electronic information to support litigation efforts. So sometimes the law requires organizations to dive into their electronic records. The firm should account for it in its archiving and data storage plans. Data can be used later and then can be stored later. Unlike analytics that promise a boost at the bottom line, there's no profit in complying with a judge's orders. In this case, it's just a sunk cost. But the organization can be compelled by court order to scavenge their bits, and the cost to uncover difficult to access data can be significant if not planned for in advance. I don't know how often this happens. I'm not privy to that kind of thing. Serverless computing. Can someone else manage this complexity? So a type of cloud computing where a third-party vendor replicates your data and then you can attack it. The costly care and feeding of a firm's technology infrastructure is often referred to as development operations or DevOps, a term I'm not familiar with myself. With less complexity, offerings can be created and delivered very quickly, but they can type an organization into proprietary technology only supported by a single firm, so you wouldn't want to do that. Like I said, my experience is all the data you want for most large corporations are in SAP and Oracle. I would imagine if you work for a hospital, there's probably a ginormous database that the hospital system or Northwestern Medical keeps on every patient everything that was ever done to that patient within the system. And I think if they're not at the point now, they're quickly at the point where if I go out of system and use Aurora Advocate or North Shore, the systems can all talk to each other and feed the data to your primary care physician's database on you. So Northwestern should know, if that's my primary care, they should know everything about me. And then how many other me's are there out there that they're finding out information about? So this is what you kind of want to do. No data science firms need your skill. So they're saying 91% of Fortune 1000 senior executives surveyed said big data initiatives were planned or underway, with half of those execs expecting efforts to cost 10 million or more. Yet, while success stories for big data abound, many organizations lack the skills. Well, every college in the world, and soon North Park, will probably have certificates in big data and do some training in this. So I don't know how accurate that statistic is. I think people are being trained in this as we speak, and I don't know what it will take to saturate the market, if the market, how big it's growing or not. McKinsey estimates that U.S. talent shortfall of 140 to 190,000 data scientists. And notice that there's analysts, scientists, and engineers all associated with data. So you got to decide what it is you do, and they've become specialized jobs now. And a further need for 1.5 million more managers and analysts who will have to be savvy consumers of big data analytics. So it's a field that's here to stay with us. People think it's a very sexy field, and some of the work that you do is, but I talk to the people that are in it, and it becomes a lot of drudgery after a while. Probably 3/4 of the time you spend on any big data analysis project is organizing and cleansing the database that you've extracted from even your own computer and others, because you've got to make sure that you're not, if there's missing data, do you want to include those records, not include those records? If things seem out of whack in a couple places, and if we're talking millions and millions and millions of lines, bits of, records of data, you can't do that by just like scrolling through an Excel sheet and saying, ooh, that number looks out of place. You've got to have algorithms to actually do that for you. So next, we want to know the tools that are available to turn data into information, identify the key areas where businesses are leveraging this data mining. You go into the mountain range of data that I talk about, and you have a mining operation to get the ore out, the data that you want, those nuggets of gold that can help you make better data decisions. Understand some of the conditions for which analytic models can fail. So there's all kinds of reports. You can have a canned report providing regular summaries of information in a predetermined manner. Well, this can be KPIs, a daily KPI, and sometimes those things are saved in a dashboard, which gives you a slick way of looking at data. And if you want to click on it to dig down further and get further information on those areas, you can do that. So it's a series of canned reports that put heads-up display of critical indicators in your hands. You have ad hoc reporting, which means they're one-off. You might not be doing it on an ongoing basis. You have online analytical processing. So it takes data from standard relational databases, calculates and summarizes the data, then stores that data in a special data called a cube. I guess I've been using online analytical processing all my life and didn't know that, what was in my cube. So it's a special database used to store online analytical processing reports. I'm pretty sure when we referred to it in our SAP, it was a shadow database of the transactional database, and we knew it was. I don't think there was much processing done to it, but I'll be the first one to raise my hand and say, well, I was naive about that, wasn't I? The Federal IT Dashboard offers federal agencies and the general public information about the IT investment. You want to see a dashboard? Go and look at the City of Chicago Department of Public Health COVID-19 dashboard. It's beautiful, and it's exactly what a dashboard is. Tableau. Tableau is a software that can take big data and make beautiful graphics out of it. So you can see, it's a really nice graphics software. There's a free version and there's a pay-for version, and the free version is designed to whet your appetite if you get really good at it. I think a lot of big data analysts use Tableau to display some of their results. Data mining. Well, it's a process of using computers to identify hidden patterns. Well, no, I don't know that. You're slicing and dicing, you're looking for patterns. I guess it is mining in that sense. But you're really looking at the database to try to find out where there's correlations, where there's things happening. You ask yourself queries and you narrow down the database that you're playing with to the items of interest that you're suspecting might have some relationships, and then you're basically taking crosstabs or correlations of it to see what it is. And I think a lot of times this is done on a big crosstabs or pivot tables kind of analysis. If you don't know how to use a pivot table in Excel, go get a video. There's plenty of them out there that explain how to do it. It's indispensable once you get a big boy or big girl job, where you're going to have to do any kind of moderate analysis. I'm talking about this kind of big data stuff. So the key areas of leverage for data mining is customer segmentation and market basket analysis, marketing and promotion, targeting, collaborative filtering and customer churn, fraud detection. That's how big banks will look at it and detect that maybe there's fraud, and then the credit card company will say, call you and ask you, are you in Fargo, North Dakota by any chance? And you call them back and say no, and they say, well, someone's using your credit card a lot there. The other thing is key areas of leverage is in a supply chain. There's so much stuff that you can use this for. If I want to redo my case size, I can look at my order patterns and I can make my cases bigger or smaller to be more reactive to the market. I've done that before. Is that big data? Maybe I was doing big data analytics and didn't even know it. Prerequisites for data mining to work. Organizations must have clean and consistent data. That's huge. It's not always that clean. Events in that data should reflect trends. Well, yeah, it'd be nice if it did. It doesn't always. If there's no trend, there's no trend. If there is a trend, yay, that's what you're trying to find. So I can't see where that's a prerequisite for data mining to work. I could mine the data, look for and then in the mined data, look for the trends, and if there are none, I go back to the mine and slice and dice it a different way. That's how I look at it. There are problems with using bad data. Well, bad data gives you bad results, obviously. So yeah, they say right there, using bad data can give wrong estimates, thus exposing the firm to risk. No kidding. When the market does not behave itself, if something changes in the marketplace. I told you I had a friend that did foreign exchange trading. He was really good at it, but his expertise and his algorithm for doing foreign exchange trading worked under a specific set of market conditions. The Great Recession hit, the dynamics of foreign exchange changed. His algorithm was useless. Is it possible to over-engineer, build a model with so many variables that the solution arrived at might only work on the subset of data used to create it? Yeah. Can you make wrong assumptions? Two people could look at the same thing, and one could say, I don't see it, and the other one looking, wanting, desiring a trend may see it that other people look at and don't see. How does that happen? I think that they're not good statisticians, if you ask me. Data mining skills. You need to know something about information technology. You need statistics and a business knowledge. And all three of those might not be in the same person. You may need 3 people, or you may need 2 people to cover that skill set. So next, understand terms such as artificial intelligence, machine learning, and deep learning. This is not my skill set here entirely, so I'm going to be skating out onto thin ice with you. Name, recognize, and give examples of popular types of AI. Understand the rise of AI and machine learning. Most of it has to do with gobs and gobs of data and cheap computing, which basically can look at all the possible combinations. And, I don't know, is that artificial intelligence, or is that like just complete enumeration of the population data? You tell me. So big data and machine learning, it's now everywhere. Computer software can mimic or improve upon functions that would otherwise require human intelligence. Data mining has its roots in AI. There's and that's probably that data mining that is beyond anything that I've ever done, where you're using cluster analysis and these things that I know of in concept, but I think I could understand them if I actually studied them a little bit. But to try to glean the patterns from the data. So we have new generation of hardware chips that are faster. We have cloud resources. We have open source algorithms in software such as R, which is pretty much entirely for statistics. Python, which is more for the data management, statistics, and operations research kinds of algorithms in it. Software development kits and data capture tools. AI is becoming more accessible, and the market is kind of exploding. So machine learning asks a question like this. Software that contains the ability to learn or improve without being programmed further. Deep learning is a type of machine learning that uses multiple layers of interconnections among data to identify pattern and improve predicted results. Neural networks examine data and hunts down and exposes patterns in order to build models to exploit findings. You have an expert system, leverages rules or examples to perform a task in a way that mimics human expertise. And I think a lot of this is being done in the reading of CAT scans and all of that. As humans, you kind of watch what humans do and then take that and put that kind of inquiry, I'm looking for this, I'm looking for that. And over time, as radiologists and whatnot classify the things, that can be put into an algorithm. And then the computer could say, I see this based on this database of previous cases. What do you think, doctor? And a doctor makes a final decision, of course. Genetic algorithms, so it's model building techniques where computers examine many potential solutions to a problem. Now, I don't know that any of us are going to get into this in any great or deep detail. And there's always a wonderful promise. There's from the Terminator movies, one of the systems all going to become self-aware and think on their own and not need us and take over everything. So issues that managers as well as concerned citizens might want to be aware of. Data quality, inconsistent data, or an inability to integrate data sources into a single data set capable of input into machine learning can all stifle efforts. Not enough data. I have an ongoing multi-criteria optimization problem that's called the supply chain, where I'm trying to minimize costs, maximize service, maximize quality, minimize inventory on 10,000 products made in 4 different factories, stored in 6 different warehouses with, a couple thousand suppliers. It's a multi-criteria optimization problem, which all the data kind of exists, but none of the equations exist to do it. I'm sure there are people who are looking at how to solve it, and I think generally we have kind of solved it by the use of SAP and sticking to the algorithms inside of there that run modern supply chains, where human beings basically look at the exceptions. The machine does all the heavy lifting and follows a prescription that you've programmed in for all the different various facets. Technical staff may require more training. AI systems involve a discipline known as change management. So change management is the system follows this business process. The human beings lagging or stuck in their old way of doing things think it should operate a different way. That gap causes all kinds of problems. Um, some data types of machine learning may be legally prohibited because the data used or the inability to identify how a model works and whether or not it might not be discriminatory. I swear to God, people don't know half the time what's happening. We try to teach forecasting methods, for example, in quantitative methods. And inside of SAP, all this is happening. We teach you forecasting so you have a feel for what's probably happening inside the machine and how it can make all these calculations faster than make your mind spin. That couldn't have ever been done before, but you're not really entirely fully sure that it's programmed properly, are you? So it's not as easy, continue on. Negative unintended consequences and misuse. That could easily happen. There's nefarious characters everywhere, and people trying to cut corners. Many workers are startled to find that in the U.S., just about anything done on organizational networks or using firms' computer hardware can be monitored. You mean they knew I went to that website? Oh my God. Firms can gain an early lead and benefit from scale, maybe in a position to collect more data than competitors. So here you have a virtuous cycle where the early winners generate more data, have stronger predictive capabilities, and have an edge in entering new markets, offering new services. Is that what Amazon is and why they can go into a new market and scare the bejeebers out of the people that are already there? All right, raise awareness of potential ethical risks and unintended consequences. So we just talked a little bit about that. Learn failure and vulnerability examples that have tipped up well-intentioned firms. Understand how organizations are working together to improve ethical use of AI. Be able to develop guidelines to develop audit and enforcement skills. I mean, AI, driverless vehicles, that's AI, feedback, learning systems, all that stuff together. How are they going to do in the rain? How are they going to do in the snow? How are they going to do in the fog? How are they, blah, blah, blah. Are they going to be better or worse than humans? And it's all fun and games until an AI vehicle, driverless vehicle, kills a few people. And then lawsuits galore. The black box nature of machine learning with multi-layered statistical weightings. It's difficult to break apart and find out what actually happened. I mean, we're programming things like crazy and not sure. I mean, there's millions and millions of lines of code floating around. And sometimes you could have a catastrophic error given certain conditions. It may be 1 out of a billion, but with the amount of transactions happening, the chances of hitting that 1 out of a billion, if you do it billions, trillions, and trillions of time, could happen. I don't know. Such systems heighten the possibility of unintended consequences, like software that crosses ethical boundaries. Earlier in this century, I guess the financial industry used derivative models so complex that they eventually contributed to the global recession, causing crisis. And people didn't know what they were doing. They were trading on their own and driving prices to extremes. We saw an example of what some hackers did with GameStop earlier this month or late last month. What if you were to program that? There's algorithms that will do nanosecond arbitrage in the stock market. I don't know how much money these people make. When I first heard people were doing it, I was like, it's like the coolest idea I've ever heard. And the weirdest at the same time, because the stock in the next nanosecond goes up 0.1%. but I bought $1 million worth, and I do that several times a minute. You're gonna make a lot of money. You can also lose a lot of money, and you don't know what really happened. You've made a video game basically out of the stock market, and it's independent and kind of devoid of the underlying business principles and structures that really should let us value stocks, right? I mean, GameStop shot up. It didn't deserve to be that high, but it was run up on purpose. It couldn't stay there, and it didn't stay there. So for some people, they made a lot of money. Other people got left holding the bag, I'm sure. We only hear about the people who make money. So these are the unintended consequences of this. And if it, just because it can be done, should it be done? That's one question. That's the ethical question. Just because it can be done, will it be done? And there will be some people that will do it and not worry about the consequences. So is your algorithm racist or sexist? I don't know. AI systems learn based on data, and then any biases in the data can become part of the model. So if facial recognition based mostly on Caucasian faces often misidentify people of color. That's bad programming if you ask me, but you got to fix that. You can't have that. You got to test the living heck out of this software to make sure it does everything. And you probably should have a database of people that you're building this on, of all different races, so that you don't have that problem, I guess. The diversity of systems development staff can influence model development without them even knowing it. AI systems may reveal bias in processes and workforce that firms aren't even aware exist. Listen, programmers, I remember working for a defense contractor that made the M1 Abrams tank, and they had a tank simulator program, which, I mean, you could play the game on the computer, which was pretty cool. But there was also a simulator that you could be sitting in, and it had all the animatronics to move the. You were sitting like in a tank, inside the tank, and it would hit the bumps. It would do this. It would that. You'd feel the jolt of the main gun going off when you fired it, etc. But a friend of mine was doing the programming for it. And when a shell hit a tank, you'd see a spray of sparks and coming off the hit tank, because a certain round actually creates a shower of like a sparkler effect, and its devastating penetration of the tank chemically. It was a chemical round. Well, each one of these globs of yellow molten metal, if you blew it up, he had designed them all to look like Pac-Man. Well, no one knows this. But you had the ability to build it, blow it up and make the screen bigger. No one ever, had a need to do that or even thought of doing, but he showed me what he did, and that was his like a little joke. Well, imagine someone's a little bit more nefarious than that. These things can easily happen. Okay, catching the Golden State Killer. Facial recognition is good when it can be used to find a lost child, but it can be oppressive in the hands of a totalitarian state on finding protesters and rooting out dissent. Well, gee whiz, we had people over on the Capitol and I don't know if they used facial recognition or not, but boy, oh boy, they didn't arrest them on site, which was, I thought, dumb. But then they found them using all the video cameras that were all over the place and arrested almost everybody. Using a well-perceived or preserved piece of biological evidence, officers sequenced the DNA of the Golden Gate Killer and uploaded it to the GED Match website, and I guess they caught the guy. The evidence was all available without requiring a warrant or court order. Crazy. So I guess the case brought to light additional issues of privacy and ethical data use. all got to be worked out. And then people will circumnavigate it if they can. And if they can, somebody will circumnavigate it. So we're in the midst of navigating a world where big data and machine learning can keep us safe, deliver social good, as well as expose others to discrimination, extortion, or public release of sensitive information. There's bad people out there that will do bad things, and if they can make money doing it, they will, unfortunately. So firms and policy organizations are being proactive. Industry leaders like Amazon, Apple, Facebook, Google, IBM, Microsoft, they're either the good guys or the bad guys, depending on how you look at it. Like I said, if you watch Social Dilemma, you probably never want to go on Facebook again. Work with additional participants such as human rights organizations that have come together to create the best practices. I'm not sure they've done well. I think social media has polarized the entire country into two big camps, conservatives, right and left, and never the twain shall meet, and both are probably full of, you have the confirmation bias of gravitating to sites that feed you what you want to hear and what you already believe. You think the internet and all of this amazing availability of information would be eye-opening and create more tolerant people. But I think, if I believe this, well, these systems efficiently can sense the kinds of things I like, and good or bad, will say, hey, here's similar things. Like if you go there and, if I go on Amazon and I'm buying books on psychology, there's a new retrospective on Abraham Maslow, it's going to suggest that to me because it wants to sell me more. Same thing with the news sites, I think, work the same principle. If someone has never ever bought a book on Amazon, Amazon is for sure not going to suggest that they read the new biography of Abraham Maslow to that person. And that person might only, buy so much hunting goods, lean-tos, tents, camping, this, that, the other thing. I don't buy that stuff very often, so it's not going to offer me the same deals it offers him. So the same thing happens. So this thing called the Toronto Declaration was crafted and originally signed by organizations from Amnesty International, Human Rights Watch, etc., call on algorithms to respect human rights. I'm sure that's happening. So the other thing you could do is hire ethicists. I haven't seen a lot of job offerings for ethicists, but who knows? Everything will be majoring in philosophy all of a sudden, so they can become with specializations in ethics, so they can get these jobs. Develop a code of technology ethics. Create a system review board. I think that's definitely important. Create and enforce technology audit trails. So expose how and when information is used. Implement strong tech and procedural training programs. And provide a means of remediation. So a study led by technology and audit firms found 43% of organizations have clear procedures for overriding AI results that are suspicious or questionable. And then lastly, we're going to understand how Walmart has leveraged information to become the world's largest retailer. Be aware of the challenges that face Walmart in the years ahead. Yeah, it's called Amazon. And everybody will copy your technology if they can. So they're the largest retailer in the world, and a source of their competitive advantage is scale. They have a proprietary system called Retail Link, and it's a records of sale and automatically, we've talked about this actually before. They records a sale and automatically triggers inventory regarding schedule and delivery. The whole thing is connected, and the reason that propelled that, this goes back to the 90s, and they've been working on that system. So they know what's happening all around the world and everywhere. And they were ahead of SAP and Oracle and other companies. But now companies that have been using SAP and Oracle are doing the same kinds of things. The The back office scanners keep track of inventory as supply shipments come in. The whole thing is geared if they're trying to get you the lowest prices all the time and availability of goods to be so that you always go in, the shelves are never empty. Um, it's just incredible the computer system they have and the advantage that it has given them. And they've not sat on their laurels, they've kept making it better and better. So you get data from varying environmental conditions, so dating their data mining prowess. Protects a firm from a retailer's twin nightmares: too much inventory, too little inventory. There's an article in the Wall Street Journal a couple years ago that talked about the reason we haven't had since the Great Recession, which was housing based, we haven't had another recession since then, except for the COVID now pandemic, which was again a different kind of recession. It's a pandemic recession. We haven't had the normal recession. The reason we have normal recessions is people stop buying goods and then the inventory builds up, and as buying slows, the inventory continues to build because the communication isn't there, and then factories start laying off people, and next thing you know, you have a recession because you start laying off people, putting people out of work, you had too much inventory, and then the people that are put off work buy even less, etc. So it snowballs. Now, the systems are and the shared services around planning that are done, like at the large consumer goods companies and auto companies, are done globally in a shared service. So people have their fingertips on it. Oh, sales are going down. Let's scale back production for next week. Obvious, logical. You can get this information almost real time, so you don't have the inventory buildup. You may have a sales slowdown, but it might only be temporary because you keep more people employed and therefore in their full salary and therefore able to buy more goods. So you might have dips, but they won't be as bad as they used to be. It's really impressive. So we don't have too much inventory and too little inventory. And it helps firms tighten operational forecasts because they can forecast on a shorter horizon. Well, it might be an 18-month rolling horizon, but it's just amazing what's been done. And data drives the organization. In other words, you're not making decisions from the seat of your pants or what ought to be or could be or think it might be. You have data telling you exactly what is happening and probably making it pretty clear what you should do next. So sharing data and keeping secrets. So Walmart shares data only with relevant suppliers. They stop sharing data with information brokers and custom builds large portion of its information systems to keep competitors off its trails. And often others respect the firm's technology. Other aspects of the firm's technology are definitely confidential. Why would you publish it? So HR meets VR. Walmart now has virtual reality headsets in the back of its 4,600 U.S. locations. And over 1 million workers have used the headsets and programs the firm has created to learn procedures. You got this virtual reality thing going on. It's kind of a flight simulator for employees to get trained to do things, to do their job better, quicker, faster, learn to do it. And I guess, companies like Chipotle and JetBlue and Fidelity Investments have used these techniques themselves. So finding huge markets or dramatic cost savings to boost profits and continue to move its stock price higher. These are the challenges for all retailers. So the criticisms are accusations of subpar wages, draw union activists, poor labor conditions at some of the firm's contract manufacturers. That's been coming and going. I don't know. I find some of their stores wonderful, others of their stores disgusting. So I don't know. Demand prices so aggressively low that suppliers end up cannibalizing their own sales at other retailers. And they've put people out of business for their pricing. And that's it, believe it or not. we finished chapter 15. What a lengthy chapter. Maybe in a future book they'll make 2 chapters out of it. Thank you very much for your time.